Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to look at the hydrolysis of esters. And so the name of this reaction is known as acid hydrolysis. Much to its name, acid hydrolysis involves an ester, an organic compound that contains an ester, reacting with a water molecule, and that water molecule is going to break the covalent bond that's found between the carbonyl oxygen and the ester oxygen. And so it's going to break this bond right here. And the product will be a carboxylic acid and an alcohol. And so here is our carboxylic acid, and here is our alcohol. So overall, this is a hydrolysis reaction, which is pretty much the reverse of esterification. And esterification, if you recall from the previous lecture video, is just is an example of a dehydration reaction. All right, so I want to go ahead and demonstrate this by looking at how the bonds break and reform by using this ester, this generic ester that you guys see on the screen as the material that we're going to be working with. And so if we have this specific ester, in the presence of a strong acid, such as H2SO4, and large amounts of water molecule, and so the water molecule is going to be in great excess. The bonds that's shared between the hydrogen and the oxygen in the water molecule and the carbonyl carbon and the ester oxygen on the ester, they're going to break. And so when they break, remember that a covalent bond is composed of two electrons. And so when they break, those electrons go back to their original owner, allowing these substances to kind of move around. And so when the OH in that water molecule shares its electron with the carbonyl carbon, we now have a carboxylic acid. And in a similar manner, when the electron from the hydrogen shares its electron with the oxygen, here we form a hydroxyl group, which is known as an alcohol. And so the product of acid hydrolysis will always form a carboxylic acid and an alcohol. And so we're going to go ahead and take a look at another example that will demonstrate this, and then we'll go ahead and do some examples on our own. And so here we have ethyl propanoate, and the ester is found inside the circle, the pink circle that I drew. And so it is this bond that's going to be cleaved, which will allow the OH to bond to the carbonyl carbon, and this hydrogen is going to bond to this oxygen. And when those bonds are completely formed, then we'll produce a carboxylic acid and an alcohol. So here we have a separation of an organic compound into two products. So one might say that this is an example of a decomposition reaction, whereas esterification is an example of a synthesis reaction for organic chemistry. And so overall, the equilibrium is driven to the right by large amounts of water. If you guys recall, the presence of this sulfuric acid, which is a strong acid, is the same. Oh, shoot. My screen is frozen again. So, if you guys recall, this H2SO4 is the same reagent that was used in esterification. And so, how would you know if you're performing acid hydrolysis or if you're performing esterification? It turns out that acid hydrolysis will only occur in the presence of H2SO4 if the reaction is driven by large amounts of water. So if there's excess water that's present, and if an ester is present, then it's most likely that that ester is going to decompose into carboxylic acid and this alcohol. Now, if initially in the reaction you only have this organic compound that's an alcohol, and you have an organic compound that contains this carboxylic acid, and if you treat it with H2SO4 and there's very little water present, then you can go ahead and produce the ester. And so acid hydrolysis and esterification are complete opposites of each other. And so I'm going to go ahead and go back a few slides, and we are going to learn how to predict the products for these organic compounds that contain esters. And so the first one that we'll do is propyl acetate. And propyl acetate is a major component that contributes to the smell of pear. Benzyl acetate is the major component that one might find in peach. And methyl salicylate is the major component for wintergreen. So typically, methyl salicylate is found in, it has that menthol type of smell to it. That's typically found in products such as like Bengay or Icy Hot, and the list continues. And so let's go ahead and do propyl acetate. Okay. And so if this is our organic compound, that would represent propyl acetate. And if I treat this organic compound with excess water, in the presence of a strong acid, such as sulfuric acid, what's going to happen is that the covalent bond between the carbonyl carbon and the ester oxygen, that bond between them is going to break. And when it breaks, the oxygen, the ester oxygen, is going to bind to one of the hydrogens from the water molecule. And so this hydrogen is going to link up to this oxygen. And then this water molecule, that bond is going to break such that the OH is going to form a covalent bond with a carbonyl oxygen. And so, I'm sorry, not carbonyl oxygen, carbonyl carbon. And so the product of this acid hydrolysis is going to form a 2-carbon carboxylic acid, which is here, and a 3-carbon alcohol group. And this would be our product. All right, and so let's go ahead and go through another example. So let's go ahead and do benzyl acetate. And so if we treat benzyl acetate with sulfuric acid in the presence of excess water, what's going to happen, maybe I should draw this, I'll write this in a different color. All right, so what's going to happen is that the covalent bond is going to break between hydrogen and OH in water, and that covalent bond is also going to break between the carbonyl carbon and that of the ester oxygen. And so what's going to happen is that a new bond is going to form such that this hydrogen is going to go with this oxygen, and this OH from water is going to form a new covalent bond to the carbonyl carbon. And so the product that we would get is a 2-carbon carboxylic acid, and the common name for this 2-carbon carboxylic acid is acetic acid, which is typically found in vinegar. And so the IUPAC name for this 2-carbon carboxylic acid is going to be ethanoic acid. So acetic acid and ethanoic acid is referring to the same thing. And so the second product is going to be this benzene ring with a carbon that's covalently bonded to a hydroxyl group. And so what we get so you just want to make sure that you have that extra carbon, and then we have the OH. Okay. And so hopefully you guys are seeing the pattern. You guys understand how this whole thing works. So let's go ahead and do the last molecule, which is methyl salicylate. And so let me just commit that to my mental memory, see if I can redraw it. Okay, let's see how I did. So I have my benzene ring with my OH, so that checks off. And then I have 1 carbon that's coming off that benzene ring, and that's going to be the carbonyl carbon. And then I have the OCH3, I have my OCH3, so I copied it correctly. So once again, I'm going to go ahead and let me just copy and paste this section so I don't have to redraw it or rewrite it. We're going to go ahead and treat methyl salicylate with excess water. And in the presence of sulfuric acid, which is a strong acid, what's going to happen is that this water molecule, the bond, between the hydrogen and the oxygen, is going to break. And the bond between the carbonyl carbon and the ester oxygen. And so when I say ester oxygen, I'm talking about this oxygen. This oxygen right here is a carbonyl oxygen. That bond is going to break. And so after rearranging our substances, we know that this hydrogen is going to go to the ester oxygen, and this OH is going to go to the carbonyl carbon. And so we're simply going to go ahead and draw a covalent bond to link those two pieces together. And so the final product is going to be this benzene ring, this phenol, if you will, with a carboxylic acid. And the second product that we're going to produce is going to be a 1-carbon alcohol. So that's methanol. And so zooming out, I'm going to see if I drew the structures correctly. I have my phenol over here, and then I have a 1-carbon carbonyl group. And so there's my carbonyl carbon, and it's covalently bonded to my alcohol or a hydroxyl group. And so when you have a hydroxyl group covalently bonded to the carbonyl group, this whole thing becomes a carboxylic acid. And so here's my alcohol, and it's covalently bonded to 1 carbon, and that would give me methanol. All right, so that's pretty much it in terms of being able to predict products through acid hydrolysis. Okay. Just make sure that you guys are drawing the correct number of carbons and that you're always producing a carboxylic acid and an alcohol. In the next lecture video, we are going to learn how to name esters.